So today we will discuss about stress and strain. So now suppose we have a rubber. This rubber of particular length. Suppose the length of this rubber is capital L, and here in this rubber we will subject an external force. We will pull it downwards, okay, with an external force Fe. And what will happen for this external force? A restoring force in this rubber will be created, which will be acting on the opposite direction of this rubber. So here the restoring force is acting in the opposite direction of this rubber, which we can say Fr, of same magnitude. Then what will happen? We will see some deformation in this rubber. The rubber will get elongated, right? And we can clearly see that here there is a change in length of this rubber, which is delta L. So what is the stress of this rubber? Here stress is equals to force over area, the cross-sectional area. So when I say about area, it must be the cross-sectional area which is representing this particular area, which is pi r square. So now let's talk about this force. So when I say the word force in stress, in case of stress, I am actually referring to this force, the restoring force of the rubber, not the external force. So this is stress. And now what is the strain? The strain of the rubber is the change in length over the actual length. This is the strain. It's pretty simple, right? Okay, so now let's think of another scenario where we will take a ball which is kind of circular in shape, and in this ball, uh, there is a volume, right? The ball has a particular volume of V, and in this ball we will subject some external force from outside, many forces from the outside. And what will happen after that? The ball will deform, right? In the same way, the ball will deform for the external force, and it will get smaller, right? And here we can see some change in volume. Here it is the delta V, it is the change in volume. So strain will be equal to delta V over the actual volume V, right? So what will be the stress? So from outside we have subjected some external force, right? Some external force. And for this external force we will get another force which is working in the opposite direction, which is actually the restoring force, right? The restoring force of that object. And here also stress is equals to force, the restoring force, over the area, the cross-sectional area, which is pi r square. In this case it is also pi r square. So now let's talk about shear stress and shear strain. For this, let us consider this is a surface, and in this surface we will take a cube which is made up of rubber. Okay, so we are now taking a cube which is made up of rubber, and what will we do after that? Obviously uh, the cube has an edge of a unit. So what will we do after that is we will exert some external force like this, and what will happen after that is a frictional force will work in the opposite direction because of the surface, right? And it will stop the cube to move permanently from one place to another. So it will slightly bend, it will tend to move, but it will not move completely, and we will find an angular displacement. So after exerting some force, we will see the cube has become like this. The cube has become like this. Okay, so here we can see that there is an angular displacement of theta, and it moved forward of distance delta x, and obviously this part is a unit, right, because of the edge of the cube. So now what is the shear stress? Shear stress, here the shear stress is force divided by area. Now which area am I actually talking about? I'm talking about that area where the force is acting upon. So here we can see the force is acting upon this part, right, this area. So this area is a square. So this is the shear stress. Now let's talk about what is the shear strain. The shear strain is the angular displacement, it is the theta. Now how can we find the value of theta? Okay, if we think this is a right angle triangle, then we can say that tan theta is equals to delta x over a. So theta is equals to tan inverse delta x over a. Okay, this is how we can find the value of theta. Now this angular displacement has a property that the value of theta must be very, very, very small. Very small. So the magnitude must be very, very, very small, so the value of theta is tending to be 0, right? So if the value of theta is tending to be 0, then we can say that its tan theta is equal to its sine theta. So these are the things we must uh, really consider while studying shear stress and shear strain.